Program activated.
Hello, I'm Dr. Somara, a mechanical engineer and broadcaster.
And I'm Dr. Simon Clark, a physicist and science communicator.
Since humanity took its first steps, it's wanted to go farther, faster, and higher.
And as our civilization progressed, humanity pushed the boundaries of speed and distance with ever more powerful engines.
But all this comes at a price, with our travelling machines accounting for around 1/5 of global CO2 emissions.
The United Nations says that aviation alone is a top 10 emitter.
Equally, our obsessions with rockets have led to 8,000 tonnes of waste into orbit.
So can we clean up our act and travel fast, furious, and responsibly?
Welcome to Mission Responsible.
You know, I learned something on a mission the other day.
What's that?
Did you know that inflammable can mean both easily catches fire and resistant to fire?
That's really not helpful.
Yeah. So long story short, I need a new tuxedo.
Okay.
That mission did not go well because I got them confused. Okay. But have you had any mishaps recently?
I mean, I'm completely thrown by that. I'm just imagining you in a burning tuxedo.
Well, it wasn't meant to be burning in my defence.
And that's where you learn that one word can mean two very different things.
Yeah. I think it's an example of an auto-antonym.
Great.
Which is another thing I learned whilst I was Googling in
Which
my...
is a mine of information, Simon.
Yeah, some of it useful. Some of it learned whilst I'm wearing a smoking tuxedo, having just jumped into a supervillain's pool. Coming up in this week's episode.
It's not as easy as, okay, I'll go and change a screw there. No, in order to go and change a screw, you need to launch something else.
This is where it starts. This is the beginning of the third revolution of aviation.
You could have a bit more fun by throwing bananas at other commuters.
So the outrageous bit of this idea is now coming out.
Yep.
So Simon, how green would you feel about flying into space? And I don't mean being sick in a space toilet.
I was one of those kids who got into physics because I wanted to be an astronaut. And to be honest, if you gave me the opportunity, if we had a Moonraker-esque mission where we had to go into space, I'd be the first to sign up.
Really?
I would love to go into space.
Even now? Now that you've done physics?
Yeah, because now that I've done physics and I know that engineers are actually the ones responsible for the calculations.
Thank you.
Would you want to go into space?
No.
Really?
I actually wouldn't. I feel like we have so many problems and challenges here on Earth that engineers can solve.
And we're messing up an environment beyond the environment we've already messed up. You know, we're causing environmental issues on Earth, but we are also... You know, I know that we are generating, when you go out in space, you're doing multi-stage rockets, you're jettisoning this and that stuff's not going anywhere. It's just hanging up there.
Can I just clarify, though? The fact that we do a lot of research to go into space, I think is really important because the extreme challenge of going beyond our planet does lead to incredible technologies that are useful here.
Absolutely, and it furthers just scientific inquiry. It's why I'd say it's one of the reasons why we're here on Earth is to learn more about the universe around us, and part of that means leaving the planet. But it does, we have to acknowledge, come with an environmental cost to it.
Yes.
We're ready for today's mission.
Definitely. All right, I'll just switch on the superfast fibre broadband and...
I'd forgotten that sound.
Login accepted. Access granted.
Welcome, agents. This week, your mission, should you decide to accept it, is to learn how responsible engineering can help us clean up the skies and space.
Space is already a vacuum.
Agent Clark, your objective is to decode ESA's Clean Space Initiative.
Wait, what kind of bin do you recycle a starship in?
Agent Somara, your mission is to track down the team developing the world's first fully certified hydrogen-powered plane.
Hydrogen. Colourless, odourless, tasteless. Just like the onboard meals.
Briefing complete. Good luck, agents. This message will self-destruct in 5.
Before you go, is there any
4,
chance we could upgrade
3,
to business class for this mission?
2, 1.
Guess I'll book the megabus again.
while Shinny jets off on her mission, I've been trying to work out what a clean space initiative is, and why we might need one. I mean, the thing about space is that it's, well, empty. Except, it turns out that humanity has done the same thing to Earth orbit as we've done to Mount Everest. Gone up there and left a load of behind. As of June 2023, there's thought to be around 6,000 to 8,000 tons of waste in orbit, ranging from frozen urine through to a wayward spatula from the Space Shuttle Columbia. While these may sound innocuous, the US Department of Defense tracks over 27,000 pieces of debris travelling over 15,000 miles an hour. I don't know about you, but having my spaceship destroyed by hypersonic frozen piss doesn't seem that appealing. My spy sensors told me I'd need to go to the very top to see how this problem was being addressed. So I arranged a clandestine rendezvous with the head of the European Space Agency's Clean Space Initiative.
Hologram programs activated.
My name is Luisa Innocenti. I studied physics in Italy long time ago, and I joined ESA in manned space and microgravity, working with the astronauts. And since 2012, I'm the head of the Clean Space Office.
So before we go any further, can you define what space debris is?
Space debris is an object done by men, so it's not a meteorite, which we cannot control anymore. So it could be part of a launcher, an upper stage of the launcher. It could be a dead satellite, which is still intact and could be as big as 4 or 5 tons, but it could also be a very small satellite. It could be a screwdriver. Some of the astronauts lost a screwdriver during the extravehicular activities. But it could also be a small object which is the result of an explosion, and therefore the big satellite becomes a fragment of small pieces, and those are as well debris.
And why is space debris a problem? Why is it dangerous?
It's dangerous because space debris travels at the speed of 7 kilometers per second, which I usually use comparison in France. I live in France, and I would say you do Marseille to Paris, 800 kilometers in less than 1 minute at that speed. So because of this, even a small debris impacting a satellite will make it maybe explode.
So this is something that we've only started considering from the sound of things in recent years. I mean, I assume that in the early space race, nobody was thinking about space debris.
No, at the very beginning, no. It's like, I always do the comparison like throwing away the plastic bottles in the oceans. We used to do that, and it took a while before we realized that we were polluting the oceans, because we thought one just plastic bottle, where is the problem? And that's exactly what we did with the debris. With the idea that space is infinite, and it's true, space is infinite, but we use some specific orbits because of their characteristic, they provide a better service. And so by now we have defined 2 regions that we define protected. One is what we call the low Earth orbit from 0 to 2,000 kilometers, and the other one is the geostationary orbit. Those were the orbits that we used the most, and therefore where we have abandoned the most the satellite, where we have had the explosions, and those are the orbits which are most polluted. In the 60s, the scientists, and in particular an American NASA scientist, started to look at it and saying, well, there is a possibility of a problem, and the name of the scientist is Kessler.
NASA expert Don Kessler pointed out that once past a certain critical mass, collisions between debris can create more debris, leading to more collisions, causing a chain reaction that could render parts of Earth orbit inaccessible for generations.
We refer to that problem of the increase of the population of debris above a limit that we could not use space anymore as the Kessler syndrome. Scientists started to alert everybody, saying there is an issue, and it took a while before the population, the operators, industry, really became aware of the problem.
So with all that in mind, can you tell us what the Clean Space Initiative is?
Yes, Clean Space was started in 2012. We are a European public organization, scientific, and because of this, we started to say, well, we should prepare a bit better. First of all, not creating debris, and second, maybe clean up the debris which exists. For example, we say that at the end of life, you need to get out of the valuable orbits. So this is typically one possible recommendation. Now, getting out of valuable orbits, at the moment, the international standard says that you need to get out within 25 years. Now we are trying to change that. The Americans have already gone down to 5 years. Another typical recommendation is that you need to disconnect the batteries from the solar array to avoid that the battery overheats and explode. A lot of the debris that we see at the moment are still due to explosion of satellites, which were launched long ago and which still have either the batteries overheating and causing an explosion, or the tanks were not emptied. So the fuel is overheating and again causing explosion. So
I'm struck by how similar this is to sustainability here on Earth, and what you've just described is responsibly disposing of objects. Is it also the case that you want to change how spacecraft are designed? So we're looking at the life cycle of objects put in orbit.
We do. Having said that, it's a bit more complicated than doing it on Earth. First of all, the cost of launch is very high. Second, once you launch, usually your satellite is up there. It's not as easy as, okay, I'll go and change a screw there. No. In order to go and change a screw, you need to launch something else, which will go there and change it. And also, design cycle of spacecraft is extremely long. We're talking about 5 to 10 years. So we need now to think about how we will design the future satellite, which will be launched in 10 years from now, and then they will be serviced. Okay, so you see that the preparation of the circular economy in space is much, much longer in time. But the idea is that in the future, we will be able to maybe change a battery which has failed, a solar array which has failed. But I think it's going to come a bit longer time.
So from a technological perspective, let's say that we have some debris in space and you want to remove it. How technologically do you do that?
The difficulty is not only to remove, but to remove it at low cost. And it's difficult. So first of all, it's an automated mission without an astronaut on board, which basically means that the satellite needs to be able to do it, let me say, by itself. In reality, it's going to be controlled by ground. So what you need to do is that you need to approach an object, a debris, which is moving in an uncontrolled way. You need to observe the object in space. You need to be sure that the images that you see are good. For example, when we observe the debris from ground, we know where they are, but we don't know how they're moving. Because from ground, we cannot reconstruct the movement. And you need to capture the object. And that's extremely difficult because you don't want to create a debris while you capture it. The last part of the movement will have to be done on board of the spacecraft without connection on ground, because we don't have enough ground station, we don't have enough time to evaluate it. So the last minutes will be done automatically. And there are different ways to capture the object. At the moment, we are studying with the Clear Space One mission, a way which is to use tentacles. So 4 tentacles which will open, encircle the debris, close it, and then fix it if you want, because then you need to re-enter or move it. So you need to have a stable connection between what is your chaser or servicer and the debris. This is a very complex operation, never done before.
Can you sum up why it's important to keep space clean?
I think that we do not realize how much our life depends on space today. Let me say, technology life. You move around thanks to GPS. My daughter doesn't know how to use a paper map anymore. That one comes from space. Weather forecast, it comes from space. We will watch the Olympic Games, we will watch football, it comes from space. The fact that we are all connected, it comes from space. So if we want to keep having those services, we need to be sure that we can use our satellite. In order to be sure that we need to use our satellite, the orbit must be clean enough.
That was a fantastic answer. I'm slightly in awe.
Data transfer complete. Hologram program deactivated.
Okay, so it seems like there are some great engineering ideas being used to make a difference. So while I grab a very long rope and start lassoing dead satellites, let's see how Shinny's getting along with her mission to understand how engineers are attempting to clean up our skies.
I'm here in Bedford to undertake surveillance on the team from Cranfield Aerospace Solutions, who claim to be developing the world's first fully certified, zero-emission, hydrogen fuel-powered aircraft. I've decided to go in using my cover identity of a glamorous tech reporter for a popular engineering podcast. So here we are, Trent House, finally on the campus of Cranfield University, and as always, it's always so interesting to get this sense that we're on an airfield. Hi, Jenny.
Hi, Ashley. Nice to see you. Welcome to Cranfield.
Nice to see you again. Yeah.
Should we take you to the hangar?
Yes.
Let's go see our aircraft. Hi, I'm Jenny Kavanagh. I'm the Chief Strategy Officer at Cranfield Aerospace Solutions.
I'm really looking forward to seeing what's happened since we last met, because my last visit, it was a very exciting time. I think you had a lot pending. There was a lot on the horizon that was about to kind of come into fruition.
So since we last met, we've now completed the design for our demonstrator, which is really exciting. And what that essentially means is that we now know what it's all going to look like. We know it's going to work. Whereas before it was more plans, and now it's actually designed, which is amazing. And we've also taken receipt of the first bits of kit. So we've got some motors that have been delivered, and we've got our heat exchanger, which has been through
a spin-off from Cranfield University. The company has received investments from both the UK government and private investors.
We're coming down to the hangar now. This is actually a really recently refurbished hangar. We had our official opening yesterday.
Congratulations.
Thank you very much. So
new hangar, new era of aviation.
That's the thinking. Yeah, we even have a banner that we've put up in the hangar with all the staff have signed it to say, the future of aviation starts here. So we're very proud of our new hangar, and it'll be where we install the hydrogen system for the first time. So it's for us, it's definitely a
new chapter.
A new chapter, absolutely that. Yeah. So. Right, here she is.
Oh, lovely.
And here, nice white shiny hangar. So mind your heads.
Being in a plain toy store.
Yeah, no, it's great. Well, we're a maintenance company as well, so we've got a lot of DA40s, DA42s in here. We do all the maintenance for L3 Harris Flying School that's based here. So all of these little aircraft are basically for them, bar a couple of privately owned ones, and we do all the maintenance.
So all these planes are either parked with their doors open, wires out. You can see a few exposed engines. This really feels like a workshop of planes, but then above us there are like pigeons that have got in and they're flying about. It's such a massive space.
Yeah, no, it's huge. I mean, this was originally the outside building is originally a 1940s hangar that was built just after the war, and essentially what this now is a hangar inside a hangar, and so it's brand new lighting and all that. But pigeons don't seem to discriminate between new and old. They just like to roost. So, yeah, they're a little family in here somewhere.
Well, it was built for flying objects, so
this is true, exactly. Yes, they have every right.
My intel suggested that they were funneling their efforts into something called Project Fresson. Rather than build a new plane from scratch, the team were converting an existing aircraft to run on hydrogen. I was keen to find out more about the aerodynamic surfaces on their test plane. Warning, the following material may contain spoilers.
So this is still the conventional version of the aircraft. We have now finished the design for the flying demonstrator, are into subsystem testing and manufacture. So we'll be flying this next year, and we'll be fitting it out at the beginning of next year with the hydrogen system. But at the moment, it's just on its still on its piston engines.
Because the last time we met, it was still in design phase.
Yes.
So you've moved on.
Finished that. We've now finished the design phase, which is great. So what that means is that we know that everything fits, at least on the CAD model. You know, when it gets into reality, something always doesn't fit. But generally, we know that the whole system is packaged inside that nacelle. We know that because we've now tested the heat exchangers, that they perform as we had modelled and expected, which is fantastic news. On the electric motor as well, that's now gone through its testing and been delivered. So we've made some real progress, and now we're just getting into the production of all of the integration parts, all of the pipes, the valves, the cables, all that kind of thing, and then the hydrogen fuel cell system itself.
It's a big deal to have everything fit because running on hydrogen requires a lot of space.
Yeah, so the tanks themselves aren't in the nacelle. The tanks will, for the demonstrator, they'll be in the cabin, but for production, they'll be on the wing. But in terms of the packaging, what we've achieved is something that nobody else has done up to this point. So we've managed to fit inside the nacelle a hydrogen fuel cell system, which is sized to produce 110% of the engine that it's replacing. And we have below the nacelle the heat exchangers that are sized for that hydrogen fuel cell system. So that packaging in the nacelle is probably, well, definitely the most volume dense hydrogen fuel cell system on the planet right now.
How do you feel about that?
Really, really proud. Really proud. I mean, it's nothing to do with me. I'm strategy, but the engineers, my God, they've pulled something really well. It is unique what they've done, and we can't wait to get it in the aircraft and flying. A lot of people, and they're absolutely right, talk about the challenge of thermal management with hydrogen fuel cell systems, and that is absolutely a challenge, and it's one that we have solved on this. But the packaging is underestimated. We have to ensure that there is never a situation inside that nacelle where hydrogen can pool, because if that happens, then you get an explosion and the whole wing goes off, which we don't want to happen. So it's been very cleverly designed to ensure that hydrogen can never pool to an extent where it's dangerous.
It's ironic to think that hydrogen is the lightest element known to man,
Yeah.
and yet it requires so much heavy material to contain it.
Yeah. But it wants to be a gas, doesn't it? And this is the thing. And it wants to leak through everything. It's a free spirit, really. So some of the weight comes from the equipment like the hydrogen fuel cell system, which converts the hydrogen into electricity. So all of the stuff around that to enable that is everything that you need to process and change that energy from chemical to electrical energy. But then, of course, the storage. So if you have a gas, it takes up so much space, you need to compress it a lot to get it into any sort of container that you could fit on an aircraft, which means a very heavy tank because it's very high pressure.
So where does this plane fit in the whole context of hydrogen-fueled aviation? Because whenever anyone does any research on hydrogen and aviation, it just becomes this like can of worms, or it's just such a complex.
There's a lot going on, which is great. There's a lot going on, right? 5 years ago, there was hardly anything going on. In fact, nothing going on pretty much in hydrogen. It's amazing how much it's accelerated. But to put it very simply, where this aircraft sits this is where it starts. This is the beginning of the third revolution of aviation.
Despite my spy training, I realised I probably wasn't going to be allowed to fly one of these planes myself. I needed to speak with the top brains on the project. It wasn't long before I was able to track them down.
Yeah, hello, I'm Rob Marsh. I'm Director of Engineering at Cranford Aerospace Solutions, and I'm also Chief Engineer for Project Fresson, which is our hydrogen fuel cell powered project.
Aviation powered by hydrogen is a very complex thing. How much does achieving your goals with this plane how far does it take you?
Well, what this effectively takes us to is a certified product. So our Fresson Phase 1 product will be a certified aeroplane that can go and fly fare-paying passengers and freight in airline service. So it's going to be the world's first certified revenue-earning services powered entirely by hydrogen and therefore emitting zero CO2 emissions at the tailpipe of the aircraft.
So then what will be the next challenges you need to address?
Well, that's our entry into service product, and these technologies are evolving very quickly. So there'll inevitably be further generations of the fuel cell propulsion system as technology further improves to extend the payload and range from an already good initial offering, something that's really compelling in the market. Also, the beauty of our system is it's scalable and to an extent modular. So we'll be able to apply this system to other larger types of aeroplane, so extended from 9-seat to 19-seat, and then potentially a clean sheet aeroplane, because it's at that stage you can take advantage of the inherent pluses of the hydrogen fuel cell system and mitigate some of the challenges it brings as well. So this is a fully scalable system that will take us quite a long way into the future.
You must be incredibly proud of what you're achieving right now.
Yeah, I think we are. I think there's a genuine pride and a genuine excitement because this has been a very challenging project. But each time we've hit that major challenge, we've taken that logical step, right, what is the issue? Apply the engineering minds to it. How do we overcome it? Create a solution and then move to the next stage.
And is the fact that you are able to test it on so much more of a practical level because you're at Cranfield and this is one of the homes for real cutting-edge research in aerospace?
Definitely. So we have excellent links with the university. That gives access to people and to knowledge. But also fundamentally, we're in an aircraft hangar at the moment. We're aeroplanes people in an aeroplanes environment. We're right on the edge of an airfield. So this is not theory. This is an engineering company of aircraft people who have a real aeroplane to convert, and it will fly from this airfield, which is both a motivation and also practically an advantage for us.
Well, it's amazing to see, and it's been amazing to chat to you. So thank you, Rob.
Pleasure. Thank you.
Mission complete. Please evacuate immediately.
Okay, now we're back at Mission Responsible HQ. How long do you think it's going to be before you can book a hydrogen-powered flight, Shinny?
Well, I think we are very close to taking domestic flights using hydrogen planes.
So over short distance.
Yeah, so more like a hydrogen taxi service in the air. But I think we're still some time away from going longer distances purely because getting that hydrogen fuel on board requires so much space because of the tanks. How about you, Simon? Do you think humanity will be able to create a cleaner path to the stars?
I think so. I definitely left talking about the subject with a sense of hope. The challenge of space was more circular than I imagined it would be, which I suppose is appropriate when we're talking about orbits. But the idea of the entire life cycle of components and of the materials that go into spacecraft, having everything being had to be minutely considered, whereas you just had to worry about how to keep hydrogen in a tank, right? That's basically what it boils down to.
It does boil down to that, but the infrastructure required to do that, you're talking about circular, this is really elliptical because it's kind of, you have to think of so many other things that don't seem intuitively part of the challenge. So how do you store hydrogen? How do you get hydrogen to the location where you can then pack it onto planes? And, all of that needs to be thought about.
It's still early days and it's tough, but let's face it, it's not rocket science, is it?
Nice.
Intelligence accepted. Your final task is to brainstorm your idea for the perfect mode of transport with Agent Cameron at D Branch.
Hello, Agent!
Is that Greig Cameron, community manager at DesignSpark, abseiling from a helicopter?
That's where the budget for this episode went.
Well, I can hardly abseil from a megabus.
Hello, Greg.
Hello, Greg.
So, agents, I'm all ears for your ideas for the perfect mode of transport for busy engineers. Remember, it needs to be fast, it needs to be green, and it needs to be a lot of fun. Simon, you go first.
Okay, so it needs to be fast, it needs to be green, needs to be fun. I can already think of a mode of transport that embodies this. I can make it better. And that mode of transport is my electric bike. I love my electric bike. It takes all the boring, hard bits out cycling. Going up hills, way easier. Pulling away from traffic lights, way easier. but you're limited by going at 25 kilometers per hour. That's when the motor stops supporting you. So I thought, have you ever played Mario Kart?
Of course not.
Of course not. So in Mario Kart, you have these boost pads that you can go over, and they'll give you this huge boost, this huge acceleration. They'll carry you up to a high speed. And if you can hit several of them in a row, you can maintain that high speed for ages. So I wondered, could we have a highway where we have these pads distributed throughout that people on their bikes can hit one after another so that you cruise at a cool 100 kilometers per hour, whatever it is.
I have to say, that does sound really fun.
And we can power them sustainably. We can have solar arrays next to the roadways. In fact, if we're going for the Mario Kart, solar pads, we can have the entire road be like Rainbow Road in Mario Kart, where we just have solar panels that you're cycling over.
I don't think you ever cruise at 100 miles per hour. You'd be frantically clinging on.
It would be less about speed and more about boosting the charge.
Yeah, it's about. I suppose the boost pads would be like those. I don't know what you call them at airports where you have the rolling roads. But we just
the travelators.
The travelators, but they're going at huge speeds. So you're getting your wheels on them, and then you skim off the top of them. Yes, precisely. And then maybe we could have items. In the middle of the road, you could have a bit more fun by throwing bananas at other commuters.
So the outrageous bit of this idea is now coming out.
Yep.
But I'm stopping you there because you are starting to almost encroach on my idea.
Oh, really?
Which is nice because it means that we're quite united on the way we were thinking.
Wait, which video game have you been taking inspiration from?
Nothing. Scaletrix.
Oh.
I want Scaletrix in real scale.
So you're sat in the front seat of this vehicle with the control, which is one trigger.
No, but it's the idea of induction charging on roads.
I see.
So all roads would be induction charging. So you don't have to faff around with plugging cables into batteries and cars and sitting around waiting. You are literally charging as you drive.
And would that be the main roads, or is this every single road in the country has now become an induction?
Ideally, every single road.
But would you need to? Because surely if you're always on the road and you're always charging, I feel like you have an overabundance of charge, if anything.
Yeah, you can feed it back to the grid.
Oh, but how do you get it from your car to the grid if you never plug in?
That's where wireless charging in the future could be really something necessary.
So by driving around on the roads of the country, you pick up charge. When you get home, you then offload all of that charge into the grid.
To cook your dinner.
I love it. I mean, Greg, I can see no engineering problems with either of these ideas.
Well, I'm really glad that you guys have gone to the gamification side of transport first. I'm actually falling on the side of Scaletrix because that's what I know.
So cool.
I'm not a Mario guy. And I've always asked the question, why couldn't we just have a giant Scaletrix?
I think because if we did, at least the way I played Scaletrix, the accident rate would be significantly higher than we currently have.
Plenty of off-track incidents.
Yeah.
Can you imagine the clean air?
Everything being electric. It would also be a lot quieter. Or they would have that Scaletrix high-pitched. Clash, clash, oh, it's gone off again.
Yeah.
We'd have to have huge cranes everywhere to put the vehicles back on the tracks.
Yeah, giant hands just coming in.
I'm imagining with both of these ideas, we would need to bring in some kind of limit control for speed, though, right?
Oh, definitely, yeah.
But it does mean that, you'll never have to use something like Waze again because there just wouldn't be any traffic.
Well, and also, if this is one of the many benefits of public transport, right? You don't have to engage your brain at all.
Yeah.
You just get on and, I know where this is going.
Yeah.
Suddenly, everybody will be able to enjoy podcasts a lot more.
Yeah.
So I'm going to go back to the guys at D Branch, and I'm going to see whether we can actually maybe test out this Scaletrix track.
Fantastic. Thanks, Greg.
Thanks, Greg.
Goodbye.
Warning, commence system shutdown.
Well, I think that wraps up today's mission.
Thanks for listening. If you enjoyed the show, please do one of 3 lovely things for us.
That's right. We'd love it if you could leave a review, subscribe to the show, or recommend us to a friend. Or for bonus points, do more than one of those.
And don't forget, you can start your very own responsible engineering journey by signing up to DesignSpark's free design resources at DesignSpark.com.
Until next time, I've been Agent Simon Clark.
And I've been Agent Shini Samara.
And this has been
Mission Responsible.
Mission Responsible was a Why Did the Chicken production for DesignSpark. Huge thanks to our guests Louisa Innocenti, Robert Marsh, Jenny Kavanagh, and Greig Cameron. The series producer was Simona Rata, the researcher was Chris Armstrong, and the executive producer was Dan Page.